today's lesson, section 7.3b. Here I know the title says double angle, half angle, and product sum formulas, but we have covered all the things in those, and so we need to start working towards the next section. So here we'll be talking about solving trig equations, which is probably one of my favorite things that we talk about all year. Okay, so here, solving trig equations, you have just regular easy ones. Now here we're not using inverses necessarily to solve these. We're using just our unit circle knowledge to help us get the angle measurements that actually produce a true equation for these. So like looking at sine of theta, they want us to find the angle measurements, so theta, that give us 1/2. Okay, so a ratio of 1/2. So if you look at your unit circle, okay, where do ratios of 1/2 happen for sine? So if we look at our unit circle, there should be 1 over here in the first quadrant, which is the point square root of 3 over 2, comma 1/2. So at pi over 6 would be 1. And then also at the opposite one, because you have negative square root of 3 over 2, comma 1/2. So then at 5 pi over 6. So you have two values that if you plug them in for sine, you would produce the answer of 1/2. Okay? And here, one thing that we'll talk about, we need to note what our range of values needs to be. So the values, or the rotations around the circle that are okay for our answers, because they may be restricted or they may not be. So if they are restricted to once around the circle between 0 and 2 pi, then these are the only values, pi over 6 and 5 pi over 6, that produce a ratio of 1/2 for sine. So our answer is going to be pi over 6, comma 5 pi over 6. Okay? Now looking at the next one, you have cosine theta equals negative square root of 2 over 2. So looking at our unit circle, where are you going to find ratios of negative square root of 2 over 2 for the x value of your points on the unit circle? So there's 1 in the second quadrant because x is negative in the second quadrant, and there's 1 in the third. And think about what points give you square root of 2 over 2, or what angle measurements. And so in the second, it would be 3 pi over 4. Okay? And in the third, it would be 5 pi over 4. Now notice how we didn't use the inverse here as well, because for A, 5 pi over 6 wouldn't have been an answer for the inverse sine, because we were restricted to our different quadrants. And for cosine, the third quadrant, 5 pi over 4 answer would not be acceptable either. But here, because you're asked between 0 and 2 pi, those are okay answers now, because we're really not doing the inverses. We're just trying to find angle measurements that complete our trig equation. So for this one, in between 0 and 2 pi, you get 3 pi over 4 and 5 pi over 4. And those would be your answers. Okay? Now let's look at when your equation would be for all solutions. So for all reals is another one that they would say, or for all real numbers. Okay? If I have cosine of theta equals 0.65, okay, now that angle is not real, or that ratio is not really on the unit circle. I know that cosine is positive in the first and in the fourth, so I know there needs to be an answer here. I don't know what the y value is, and then I also know it's got to be in the fourth because x is positive there, but I don't know what the y values are there. Okay, so here we do kind of need to use our unit circle to help us out. So let's plug that in. So the inverse cosine of 0.65 is going to be 0.86. So that would be this one, okay, in the first quadrant. Now, to get the fourth quadrant one, remember it's a reflection over, okay? So it would be going the opposite direction. So if you go the negative of that, you get negative 0.8632 or whatever, okay? So the negative of that, if you add 2 pi to that, you get 5.42, and that would be this one, okay? So what I did there is I multiplied this by negative 1, got negative 0.86, and then I added 2 pi to that to get this one, because that would be because these are the same distance t from 0, so that 0.86 is true, the same distance to the other, to the negative 0.86, and then just adding 2 pi to get it in between 0 and 2 pi, okay? Just like we would for the intervals for the last problem, where it's in between 0 and 2 pi that we want our answers, okay? Now this one's a little different, as we want all the answers. So these are just 2 of the answers. They're not all of them. Okay? So to show that we get all of them, let me show you in green here, is if I'm looking at this point, okay, the next time it's going to happen is if I go around the circle and come back. But that's like adding 2 pi to it, right? To get to that same value. It's going to be a different number, radian measurement, but it's at the same spot, so it's going to produce the same ratio of 0.65. Okay? What if I did it again and went around again? That would be another one. Okay? And I could do that in every direction, both clockwise and counterclockwise. So to represent those all without having to write every single one, because there's infinitely many, I want to write plus 2 pi, because that's a rotation, times k. Okay, the k represent any integer that you could plug in that would represent the number of times you would go around the circle. So if you plugged in 100, that means you're doing 100 rotations around the circle, because you're taking that times 2 pi, and then you're adding it to your value, so you're getting a coterminal point, 2.86, but it's at a different, like, you've gone around the circle 100 times to get to that value. Okay? You want to do the same thing to 5.42, because you're going around 2 pi, so like 50. If you put in 50 for k, that would be the coterminal angle or terminal point for, or to 5.42, but it's 50 times around the circle to get to that same coterminal point. Okay? So that would be my answer for cosine. That's how I show all the solutions without having to write every single one. Okay? Now for tangent, now this one's a little different. If I have tangent of 2, okay, you can't really represent that in the same way on the unit circle. Okay? If I got 2, I know it's positive, so it's got to be in the first quadrant, or it's got to be in the second quadrant. Okay? But I don't really know what my x or y are, but I kind of do, because you have the points, like it's the ratio of sine over cosine, so it's like having the point of 2 over 1 and then negative 1 over negative 2. So you kind of know those points, but you really don't see those on the unit circle because your r is different. Okay? So it's a different r value that creates that, those points. So here we need to use our inverse tangent function to help us out. So put in the inverse tangent of 2. Now remember, for both of these problems, we're talking about radians, so make sure your calculator is in radians, okay, to be able to do this correctly. So I punch that in, I get 1. So let me use a different color here. So that distance right there, t equals 1.11, let's say. Okay? So that is my t value. So that's one of the values, or one of the answers right there. Okay? Just like 0.86 was. But I want to be able to represent the other one all the way over here. Okay? So how do I do that? Now, how far away are they from each other? Well, if you think about tangent and how it kind of is every pi, its periods every pi. So that value is actually 1.1 plus pi away. Okay, but if I went the other direction with this one's actually 1.11 plus a negative pi. So they're actually the same distance around the circle because it rotates every pi. It's not like cosine and sine where it repeats every 2 pi. So tangent is a little different where you can actually, for all the solutions, you can actually represent each answer, if you're doing all solutions, by just doing 1. So for theta here, you got that first one 1.11, but because it repeats every pi instead of every 2 pi, and that kind of couples up with this one, so it'll be the same. I can say, instead of saying plus 2 pi k, I can say pi k, or plus 2, or just plus pi k. So the k represents how many pi's you're going around the circle, so it's like half of the circle to get to that same point. But I'm catching all of the solutions at the same time. Okay, that one, if you need to, we can go over that in class because it's a little harder to do. Just like talking it through with you, kind of need to be a little bit more visual with that. Okay, so if you need to go over those problems, just let me know. Okay, have fun. Bye.